So it's time to look at the standard form of the quadratic function, which is y equals ax squared plus bx plus c. A is the coefficient of your x squared term. As we saw already, it can be positive or negative. It can be really high. It can be really close to 0 a lot of the time. On the parent quadratic function, it's 1. If y equals negative x squared, a will be negative 1. And it has a lot to do with how your quadratic function is going to look when you graph it as a parabola. It decides whether the parabola opens up or down. It decides how narrow or wide your parabola is. And those two things completely determine the shape. The c does not have a variable next to it. It's not an x squared term. It's not an x term. It's just a number all by itself. And c, we already saw, is the y-intercept of your graph. And it has the effect of just shifting whatever parabola you have up or down. We call the coefficient of our x term b, and we haven't seen one of those yet, so our b has always been 0, because 0 times x is 0, and we don't have to write that. But what we will find out is that the b shifts the parabola to the left and to the right in a strange way. And once again, this is called the standard form of a quadratic function. We like to get our x squared term in front, our x term in the middle, and our constant term in the back. These are the only 3 types of terms we're allowed to have in a quadratic function, because if we had an x to the third or anything bigger, it'd stop being a quadratic function. It'd become different kinds. And we can't have any other variables because this is a function that goes from our input x or output y. A, b, and c aren't inputs or outputs. They're just, they always have to turn into numbers before we actually get a quadratic function. In quadratic functions, this expression is actually a polynomial, so you can't have any exponents that aren't whole numbers. So the only options are x to the second power, x to the first power, or x to the 0th power, which is just 1. So that leaves us with just our constant term.